चलें जी, Bismillahirrahmanirrahim. This is lecture number 10. Title is Zener diodes and applications. And today we will do one or two very interesting circuits composed of Zener diodes. चलें जी, so we will start. The title of the slide is Zener diode with AC input. And we want to see the output of an electric circuit which consists of two Zener diodes when we are giving an AC input voltage. So let us first of all look at the circuit. The circuit consists of a series resistance Rs. Then we see two diodes D1 and D2. These two diodes D1 and D2 are in fact our Zener diodes. And the breakdown voltage of each diode is 10 volts. The input voltage that we are giving is a square wave which has a certain frequency, and the peak to peak voltage is 100 volts. The square wave during the positive half, the amplitude during the positive half, or the peak voltage during the positive half of the square wave is 50 volts, and the peak voltage during the negative half is minus 50 volts. So we are giving this positive 50 volts to negative 50 volt square wave AC voltage to the input of our electric circuit. The electric circuit consists of resistance Rs and two Zener diodes D1 and D2. Each Zener diode has a breakdown voltage of 10 volts. Now, if we look at the Zener diodes, they are connected in series, but they are connected in opposite polarity to each other. That is, the anode terminal of D1 and anode terminal of D2 is connected to each other. It is common. And one cathode terminal is connected to the ground. We will have our ground over here. We will have our ground over here. The cathode terminal of D2 is connected to the ground, whereas the cathode terminal of D1 is connected to the series resistance Rs, and we are taking output. We are taking our output voltage across D1 and D2. This is our V out. We are giving input voltage between resistance Rs and the ground. This is the input voltage. And our input voltage is a square wave AC with peak to peak voltage of 100 volts, and it is 50 volt, positive 50 volt during the positive half and minus 50 volt during the negative half. So we want to see what is the output voltage when we connect two series Zener diodes with opposite polarity. Now let us start the analysis. First of all, what will happen from 0 to pi? This is pi over here. What will happen from 0 to pi? From 0 to pi, we have the positive half. We have the positive half, and the amplitude of the input voltage is positive 50 volt. Now when we give positive 50 volts to the input of Rs, what will happen? The diode D1 will experience breakdown because the Zener voltage breakdown of D1 is 10 volts, whereas diode number D2, it will experience forward bias. And yes, we are assuming that Zener diodes D1 and Zener diodes D2 both are ideal. That is, when they are forward biased, they will create 0 volts, and when they are reverse biased or when they are experiencing Zener voltage breakdown, the voltage will be equal to the respective Zener voltage breakdown voltage. So during the positive half, that is from 0 to pi, we give positive 50 volt at the input. Zener diode D1 becomes reverse biased and Zener diode D2 becomes forward biased. Now, what is the output voltage from 0 to pi? The output voltage from 0 to pi is positive 10 volts. So this first yellow region we get during the positive half. The output voltage is only 10 volts. And during the positive half, D1, Zener diode number D1, during the positive half, Zener diode D1 experiences Zener breakdown, and during the same time, that is from 0 to pi, the Zener diode D2 is experiencing forward bias. Hence, we will get an output of positive 10 volts. From where did this positive 10 volt come from? This positive 10 volt in fact comes from the Zener breakdown voltage due to only D1. Since we are assuming that both Zener diodes are ideal, therefore we will not consider, unless stated, we will not consider the 0.7 or 0.3 barrier potential. So during the positive half from 0 to pi, the output voltage is positive 10 volts, and this positive 10 volt is contributed by only D1. कोई question यहाँ तक?
The Zener diode ideal है?
Yes, ये हमने पहले ही तय कर लिया है कि दोनों Zener diodes हमारे ideal हैं. Any questions so far regarding the waveform?
It is a voltage regulator.
No, it is not a voltage regulator. It is in fact a voltage clipper with controllable output, and we are controlling the output using two Zener diodes.
Okay. And sir, what
Okay.
if we apply 9-volt pulse?
Yes, I will come to this question, but in just in a later while. Okay, so this was the discussion from 0 to pi. Now we are going to discuss what will happen during the negative half. That is what will happen when we supply now we will see what will happen Okay, now for the second part, we want to see what will happen from time pi to time 2 pi. What will happen when the input voltage goes through time pi to 2 pi. During this time, the input voltage is minus 50 volt, and the polarity is such that RS is negative and the ground is positive. And here we have the input voltage like this, V in. So we want to study that during the negative half from pi to 2 pi, out of the two diodes D1 and D2, which diode is forward bias and which diode is reverse bias. So when we have a minus 50 volt from pi to 2 pi, during this time, current will flow through D2, through D1, and then through RS, and then back to the power supply. Therefore, since both Zener diodes have Zener voltage of 10 volt, therefore, during time pi to time 2 pi, the diode D1, it is forward biased because the current and the diode direction are the same. So therefore D1 is forward biased. But at the same time, we must not forget that our input voltage is minus 50 volt, and minus 50 volt exceeds the Zener voltage of diode number D2. Hence, diode D2 experiences Zener breakdown voltage. It is diode D2 is reverse biased, and also the diode D2 experiences Zener breakdown voltage. Therefore, in the output voltage from time pi to 2 pi, the output voltage is minus 10 volts. And this minus 10 volt is contributed by D2 alone, by Zener diode D2. Whereas Zener diode D1, it is forward biased. And since we are assuming that both diodes are ideal, therefore we will not consider the 0.07 or 0.03 volt of the barrier potential of either diode which is forward biased. This is a general statement. So what we have achieved is that we have clipped away, we have removed certain voltage of the input, and we have got output voltage which corresponds to the Zener voltage of diodes D1 and D2. So this was the theory of Zener diode with AC input. Now we are going to discuss the case when the input voltage is less than the Zener breakdown voltage of diode D1 or diode D2. In this case, let us assume that we are connecting a DC power supply of positive 9 volts such that the negative terminal of the battery is connected to the ground and the positive terminal of the battery is connected to RS, and the magnitude of the power supply is positive 9 volts. यही सवाल था आपका?
Yes, sir. यही था.
The diode D1 has a Zener breakdown voltage of 10 volts and diode D2 has a breakdown voltage of also 10 volts. Both diode D1 and D2 are reversely connected in polarity. So with a voltage of 9 volts, which is less than Zener breakdown voltage of D1 and D2, when we give a 9 volt voltage, this 9 volt is not enough to break down the Zener diode D1. Therefore, Zener diode D1 will be open circuit. During this time, D1 will be open circuit. If D1 is open circuit, then no current flows through the total circuit. Therefore, RS has a voltage drop of 0 volt, and current through D2 is also 0 ampere. Hence, the output voltage, I will write over here, the output voltage Vout is equal to 9 volts alone, or positive 9 volts to be exact. So input voltage is less than the Zener breakdown voltage of D1 and D2. Therefore, this input voltage cannot break down our Zener diode, either D1 or D2. Now, D2 can never experience Zener breakdown because it is forward biased with respect to the direction of our power supply. So D2 is out of the question. We are interested in D1 because D1, for the connection of the battery shown, D1 is in reverse bias condition. But the diode D1 will still not present Zener breakdown until input voltage is larger than its own Zener breakdown voltage. Therefore, for a 10 volt Zener breakdown, 9 volt is not enough to break down our Zener diode D1. Hence, current will be 0 because diode D1 is open circuit. Therefore, output voltage is positive 10 volts. Now we come to the second part, when the input voltage is minus 9 volts. That is when the polarity of the input power supply changes such that now the negative terminal of the battery is connected to RS and the positive terminal of the battery is connected to the ground. This is the positive and the potential is now minus 9 volts. With this polarity shown, with the polarity of the power supply shown, out of D1 and D2, which diode should be forward biased and which diode should be reverse biased? So by looking at the face of the circuit, D1 should be forward biased, whereas D2 should be reverse biased. Why am I saying this? Because if current flows, then current will support the direction of D1, but current will be opposed by the direction of D2. For this reason, I'm saying that D1 will be forward biased, D2 will be reverse biased. Now, after this, let us look at the amplitude of the DC input voltage. It is minus 9 volts. Minus 9 volt is not enough to break down. Therefore, this time diode D2 will experience open circuit. With diode D2 now open circuit, no current will flow through D1 or RS. And if there is no current flowing through RS, this means that voltage drop across RS is 0 volt. And for this reason, the output voltage is minus 9 volts. So V out from time pi to 2 pi is equal to minus 9 volts. So to summarize, if the input power supply is less than the Zener diode breakdown voltage, then the output will follow the input. But when the input voltage exceeds the Zener breakdown voltage, the output will be locked at the Zener breakdown voltage of that diode which is reverse biased. This is a general statement. That is, when our input voltage exceeds the breakdown voltage of the Zener diode, then we will have an output equal to the voltage of Zener diode which is reverse biased. Any questions so far?
यस सर सर एक आपने ना एक पीछे ग्राफ दिखाया था जिसमें ना जीनर इनपुट और जीनर आउटपुट का ना लीनियर रिलेशन होता है जब उसका ब्रेकडाउन वोल्टेज अचीव होने से पहले, उसके बाद वो कांस्टेंट हो जाता है सर। इसमें तो वो फॉलो पता नजर नहीं आ रहा।
So you are mentioning this graph, right?
यस सर।
This graph shows that as long as the input voltage is less than the Zener voltage, the output voltage will follow the input voltage because the current is zero. The same theory we are applying over here. That is, when the input voltage is less than the Zener diode of D2, for example, we are giving minus 9 volt to the input. This minus 9 volt will not reverse break down D2. Therefore, D2 is open and our output is also 9 volts. Our output is following the input voltage. Our output voltage is following the input voltage. So we are aligned with the theory as mentioned in the previous lecture.
Yes, sir.
Let us now use a power supply of 5 volt. Now what will happen? With power supply of 5 volt being connected such that the negative terminal is connected to the ground and positive terminal connected to RS. Which diode out of D1 and D2 is forward bias and which diode is reverse bias? So D1 is reverse biased RB, whereas diode D2 is forward bias. Correct? Everybody following me?
Yes, sir.
Okay. Although D1 is reverse bias and although D2 is forward bias. But now let us look at the Zener breakdown values of D1 and D2. Both diodes have Zener breakdown values of 10 volts. Will D1 experience Zener breakdown voltage?
No, sir.
No. The diode D1 will not experience Zener breakdown voltage because we are giving only 5 volts. Therefore, what will happen to D1? Diode D1 will become open circuit. These two dots are showing an open circuit, and I will write over here that D1 is open circuit. Open. So with a component open circuit, will we have any current in the circuit? We will not have any current in the circuit. Therefore, no voltage drop across RS, and whatever voltage we are giving to the input will now be available at the output. So V out is equal to positive 5 volts. Okay, students, thank you very much. I will finish the class over here. Please study from the textbook, go through this slide that we have done today. Try to simulate it in some simulation software, and you should have the similar results. You can also change the waveform of the input voltage and observe the output voltage. Thank you very much. Yes, Assalamu alaikum.